All right, children. So this is our lesson 3-1 video. We're talking about solving linear systems of inequalities and equations. Mostly we're going to focus on the equations. Solving linear systems of inequalities is really, really visual and intuitive, and it doesn't require too much instruction. So here's our EQs. How are we going to use graphing to solve both linear systems of inequalities and equations? And how do we use substitution and elimination to solve linear systems of equations? And how can we formulate linear systems from real world situations? And we have an interesting situation on this one. Okay, so first things first. So here we're being asked to solve this linear system of inequalities, right? And you don't really solve them so much as you find the solution area where your solutions can exist. Okay, so to show you what I mean, I'm just going to go ahead and use Desmos. And let me drag it over here. Okay, so we've got three inequalities, and let me make this more visually friendly. There we go. So y is greater than or equal to 5, right? So we see we've got a solid line right here at y equals 5, and everything above this is shaded because we're talking about y is greater than or higher than or equal to 5. And we're including 5 itself with a solid line here. Okay, then we include x is less than or equal to 10, right? And here we clearly see, right, so this is x equals 10, and everything to the left of it, including 10, and everything to the left of it is shaded in here in blue, right? So this means we're including the value of 10 because we're saying less than or equal to, right? Well, then we throw in this linear equation. Y is less than 2x plus 3, right? So this equation, if we look at the dotted line, it represents the equation y equals 2x plus 3, right? And of course, it's not an equation, it's an inequality. So why the dashed line? Well, because we're saying less than. We are not including the values of 2x plus 3, right? We're including everything to the left of this, or sorry, to the right, right? And I shouldn't say right, I should say below, because if we're talking about y, right, we're talking about vertically. So everything below that equation line, not including the equation line, that's why it's dashed, right? And you see a triangle in here, this triangle formed where they all three, every one of these, right? So y greater than or equal to 5, x less than or equal to 10, and y is less than 2x plus 3. All of these overlap in this little triangle here. This is our solution area, okay? And what that means is any point, and I guess I should have just left that up, any point that's on here, that's in that solution area, so let me just think of a point that would be in there. So anything, so like right here, for example, that looks about, we'll call that 8 by 12, right? So 8 by 12. And we see this is in the solution area. So this satisfies this system, right? This is a point wherein y is greater than or equal to 5, right? It's 12. X is less than or equal to 10. It's 8. And y is less than 2 times x plus 3. So 2 times x, 2 times 8, 16 plus 3 would be 19. Okay, so we see that this is obviously within our solution area. Okay, so any other point would also be in our solution area and thus make this system true. Okay, so any problem that you see from this is going to simply include that we graph each of these and we shade them in, right? So here's our XY axis. Let's say, so y is greater than or equal to 5. That would just be a straight line across here. We would shade up here, right? And I'll use a different color. Then we'll do x is greater than or equal to 10. So that means everything, less than or equal to 10. So that means everything to the left of that, right? And then this guy here, which we already saw the picture for, right? And this triangle where they all three overlap is our solution area. Okay? So it's pretty straightforward, pretty visual and intuitive. Not going to spend too much time on it. Right? So what about that same logic applying to linear systems of equations now instead of inequalities? Right? Well, that logic still applies. And let me adjust the size of this window if the stupid mouse will allow me. Really, bro? Okay. So I'm going to make it about this large. That'll work. And I don't think I can make that any smaller. Okay, so if I graph both of these, so y equals x plus 1 and y equals negative x plus 4, we'd see a clear point of intersection, right? This point of intersection, 1.5 by 2.5, those are the values of x and y where both of these statements, both of these conditions are true, namely y equals x plus 1 and y is equal to negative x plus 4. And we can find where x and y satisfy this simply by graphing and finding where they intersect. Okay? So the point 1.5 by 2.5 is where these two intersect, and it's where these two are true at the same time. Okay, so 1.5 by 2.5. And you're going to see what's going to happen. So if I plug in for x and y, right, so 2.5, I'm going to do this one first. So 2.5 is equal to 1.5 plus 1. Well, obviously, that is 2.5. So it's true there. Well, let's try it here on this second one. 2.5 is equal to negative 1.5 plus 4, right? And we, of course, know that also to be 2.5. So again, we see it's true in both cases, which is why we see this point of intersection here. Okay, so now let's look at another example here, number 2. So y equals 2x plus 5 and y equals 2x. So let me pull my graphing calculator back up, so clear these off. Okay, so 2x plus 5 and 2x. Okay, so you may remember from geometry, you can clearly see that these two are parallel because they have the same slope. Because they're parallel and have the same slope, right, they never intersect. Okay, and because they never intersect, we simply say this system has no solution, right? Well, then here on number 3, and I'm not going to show you the graph for this one just yet. Okay, so this guy is written in slope-intercept form. This guy is not, right? But we can easily get it in the slope-intercept form. So 2y equals 2 plus 4x. I'm just going to divide everything by 2. That's going to give me y equals 1 plus 4x. And if I switch things around into mx plus b, well, you see 4x plus 1, right? Oops, what's the matter with me? I didn't divide by 2. This should be 2x plus 1. Whoopsie! You guys probably saw it on the video and were like, what's wrong with this guy? Anyway, so divide by 2, right? So we see that we get the exact same equation both times on this set, right? So what does that mean? Well, that means that they're both the same equation. That means they have infinitely many solutions. Okay, infinitely many solutions. So that's why it's important to understand how to convert between standard and slope-intercept form. And that's where this is really going to come into play a little bit here when we do elimination. But let's talk about how can we solve these systems algebraically. So what we saw was graphically, right? We use graphing. Okay, now we're going to use algebra, namely substitution, right? And what's that's going to entail is, so if x equals 25 minus 3y, right? Well, what is x? What is y? So we can solve this using algebra and not graphing anything if we don't want to. Okay? So I know x is equal to 25 minus 3y. So I can take what x is equal to and plug it in here for 4x. So I can say 4x, right, because that's what x is, 4x plus 5y equals 9. And of course, I'm using this equation here from the system. Okay? So now you see I'm only dealing with one variable, which means I can easily just do some algebra and solve for y. So I'm going to distribute 4 times 25, 100. 4 times negative 3y minus 12y plus 5y equals 9. I'm going to go ahead and combine like terms here. Oops, not there. There. And I get 100 minus 7y equals 9. Now I just need to get y by itself, right? So now I've got negative 7y is equal to 9 minus 100, which of course is negative 91. Divide by negative 7 on both sides. Okay, and we get that y is equal to positive 13. Okay, so we know what y is now. So I can take this y and plug it in over here for this y to find x. So x is equal to 25 minus 3 times y. Whoops, I literally wrote y instead of what it was. Okay, so that's going to be equal to 25 minus 39, right? And y is going to be equal to, if I'm doing, or x is going to be equal to, if I'm doing the math in my head correctly, negative 14. Okay, so that's simple, right? And of course we can check our work just like we did before. So x is negative 14. If I plug that in for x, and 25 minus 3 times y, right? I'm going to end up with 25 minus 39, which of course is in fact negative 14. And if I try it here on this one, 4 times negative 14 plus 5 times 13, that should be equal to positive 9. So 4 times negative 14, that'd be negative 56. And 5 times 13 would be positive 65. And that, of course, would combine to give me 9. So I know my solutions are algebraically sound and correct. Okay, so now let's look at one that's not so cute, right? So the idea, if we look at example 2, the idea behind that one is we're going to have to get one of the variables by itself. Right? And I'm going to start here with this second equation, because that one looks like it's going to be the easiest one to get a variable by itself, if you ask me. Right? So if I just come over here, so 2y equals x minus 10. If I just add 10 to both sides, 2y plus 10 equals x. And I can do the flipperoo and say that x equals 2y plus 10. Right? Either way, I have x by itself. Okay, I don't know if you're like me and you maybe like to have the variable on the left. But anyway, so we know what x is. So I can go ahead and plug in x over here in the other equation in the system, right? So x, which is 2y plus 10, plus 2y is equal to 14. Now I only have one variable and I can easily solve for it, which is y. Okay, so I don't need these parentheses. There's nothing being distributed into them. So I'm going to go ahead and just drop them. So what I've really got, I'm like positive I clicked on the eraser. What I've really got is 2y plus 2y like terms there. So 4y plus 10 equals 14. Subtract 10 from both sides. 4y is equal to 4. Divide by 4. Y is equal to 1. Now that I know what y is, I'm simply going to go ahead and solve for x. So I'm going to take my y and plug it in here. Okay? So 2 times y is equal to x minus 10. So obviously this is 2. Add 10 to both sides. 12 is equal to x. And then, of course, just to make sure, I'm going to check my work. So I'm going to use this equation first. X plus 2 times y is equal to 14. or 12 plus 2 equals 14, which we know is true. And I'm not going to bother checking it in the other one because if it's true in one, it's more than likely true in the other. Okay, so I'm going to leave it at that just to keep this video short. Substitution's not very difficult, but you can see there's a lot to it, right? So the key is to always, and let me, here, before I mess that all up. So before I mess this all up, right? So another way to express your answers is as an ordered pair. So my solution set to number 2 would be 12, 1, meaning x is 12, y is 1. X is 12, y is 1. Okay, just needed you to see that, so that way when you see on the solutions for the actual practice, you're not like, what does he mean? Okay, so now let's look at another way, elimination, right? So this is more of an algorithmic way to do this. So you see I've got both of these guys expressed in standard form. AX plus BY equals C. Okay, that's important. That's important. Okay, it's good to have it expressed in standard form if you're going to use elimination. I like to just think of it as putting them in alphabetical order, right? But you'll see why here in a second. Okay, so if I write these two out, one on top of the other, negative 2x minus 3y equals 5, negative 5x plus 3y equals negative 40, right? What you want to do with this algorithmic method of solving systems is look for where you can cancel or eliminate a variable. In this case, the minus 3y and the plus 3y, they would combine to give me 0, right? So you can think of it as like an addition problem, right? So combine down, so 5 combined with negative 40, well, that's negative 35. Negative 3y combined down with positive 3y, well, that's 0y, or just 0. We can say that it's just gone. And then negative 2x, negative 5x, that's minus 7x. Right, so what we're really left with is negative 7x equals negative 35, since that y is just 0. Divide by negative 7 on both sides, and you get positive 5, because negative 35 divided by negative 7 is positive 5. So we already know our first variable, x, is 5. Now I can just substitute like I did previously, right? So I'm just going to take that x equals 5 and throw it into this guy. So negative 2x minus 3y is equal to 5. Okay, so this gives me negative 10 minus 3y equals 5. Add 10 to both sides. Negative 3y is equal to 15. Divide by negative 3. And we get that y is equal to negative 5. Okay, and of course, you want to check your work. Okay, so negative 2, and I'm going to use this same one because it's the prettier one. Negative 2 times x minus 3 times y is equal to positive 5. Let's see if that's true or false. This is negative 10. This is going to be plus 15. And of course, we see negative 10 will combine with positive 15 to leave us with 5. So we know our solutions for x and y, our solution set here, is correct. 5 by negative 5. Okay, one more example. And this one's not going to be so pretty. Right, so this one was easy because we didn't have to do anything cute to make the elimination happen. We just had to combine the two equations, quote unquote, right? This one, it's not going to be the case. So if I write them stacked, so 5x plus 6y equals negative 14, maybe, over x minus 2y equals 10, right? I can't just combine down and get something to eliminate like I could before. But what if I multiplied this equation here on the bottom, the entire thing, by 3, right? If I multiply by 3, surely that will give me a negative 6y here, right? And that would combine with the, and actually, I don't want that. Oh, yeah, I do. I accidentally marked it out and thought it was negative. Anyway, I do want that. because the plus 6y, the minus 6y, those will combine into 0. Okay, but I can't only multiply this guy by 3. I have to multiply here and here also by 3. So basically distribute 3 into the entire equation. So this gives me 30 over here and 3x over here. And then I don't need this anymore. Okay, so I'm going to scratch that out so I don't confuse myself. And then I'm just going to combine down. Negative 14 and 30, well, that's going to combine into positive 16 plus 6y minus 6y, that's 0. And then we have 8x, right? And that leaves us with 8x is equal to 16, therefore x is obviously 2. Now that I know what x is, I'm going to throw it in here to this guy because it's the cuter looking one. So x minus 2y equals 10. Solve this little guy. Subtract by 2 on both sides. Negative 2y equals 8. Divide by negative 2 on both sides. Y is equal to negative 4. Right? And again, let's check our work. So I'm going to use this same equation. Okay, so x minus 2 times y is equal to 10. 2 plus 8 equals 10. We know that's true. So we're good. So now we see a real world example. Okay, so we've learned all kinds of methods to this, but now we're going to apply it to a real world example, sort of. Okay, so our real world example is going to involve Yareni, who's probably going to want to stab me after this because I'm probably saying her name wrong, but whatever. So let's say she's finally challenged her insatiable violence into something positive. She started her own boxing gym. And she's offering a package deal of 12 group lessons and 2 private one-on-one lessons for $110 total. She is also offering another package deal for 10 group lessons and 3 one-on-one lessons for a total of $125, right? So if we look at this, right, so number 1 is asking us to write a linear system that represents this, and we can easily do that. So 12, G represents the cost of group lessons. So 12 group lessons plus the cost for the private lessons. So it's 12 group lessons, 2 private lessons, says right here, right? And that's equal to $110. Okay? Well, then you also have 10 group lessons, so 10G, plus 3 private lessons, so 3P, and that's equal to a total of $125, right? So I'm going to go ahead and tell you right now, elimination is usually the simplest way to go all the time. Okay, substitution gets really ugly, especially when we get, so these are what's called 2x3 matrices, right? So there's, you can think of it as there's 2, and I always get rows and columns mixed up, but there's 2 rows and 1, 2, 3 columns. And I probably said that backwards. I don't know. I'm not an English teacher. But anyway, so this is a 2x3 matrix. So when we get into 3x4 matrices, right, elimination is going to be the way to go pretty much all the time. Substitution is brutal on 3x4s. Okay? But anyway, I'm getting carried away. So we're going to go ahead and do elimination here, but it looks like the simplest thing to be eliminated would be P, right? But how, right? Well, if I multiply this guy on top by 3 so that this 2P becomes a 6, positive 6, and I multiply this guy in pink by negative 2, this will become a, what do you call it? Negative 6, right? So let's go ahead and see what that would look like. And I'm going to have to write tiny here. I didn't give myself enough room. But this is going to be 36G plus 6P equals 330. Okay, now I'm going to multiply the second equation here in the pink by negative 2. So that's going to give me negative 20 minus 6P, which is what we needed. And that's going to cancel here with the plus and is equal to negative 250. Okay, so we're going to combine everything down. So that's going to give me equals 80. And then this is going to be 0P and 16, forgot the G, 16G. right? So we simply have 16G equals 80. That means G, when we divide by 16 on both sides, is equal to 5. Okay, so let me erase some of this mess here. I had to come back and edit the video because, this software doesn't let you pause recordings. So anyway, so if G is 5, that means I can just plug into this guy here. So 10 times G plus 3 times P, which we still don't know, equals 125. We can easily solve this. So 50 plus 3P equals 125. Subtract 50 from both sides. 3P is equal to 75, right? And when we divide by 3 on both sides, we get that each private lesson costs 25, right? So what do our solutions mean? So we solved the system. P is 25 and G is 5. Well, our solutions mean that the private lessons cost $25 each and the group lessons cost $5 each. Okay, so like always, if you have any questions, shoot me an email or obviously feel free to ask me during class. Other than that, goodbye.